Let's say you have a circuit like this. Okay, this is R1, this is, let's say, epsilon, this is R2, and this is R3, and there's a twist here, and twist is that there's a capacitor here, like so. Its capacitance is C. Okay, and this is switch S. The switch, when switch it is turned on, okay, the circuit's gonna look like this. Alright, so what will happen is, because of the potential difference epsilon, this capacitor will charge. So I'm just gonna talk about what happens at t equals to 0, that is just the moment after switch is turned on, and what happens when t is equals to infinite, that is a time that, like, a significant amount of time has passed after the switch is turned on. So when t is equals to 0 is considered, this entire circuit is changed, and the change that you should see is, okay, let me really quickly copy this and paste here. So when t is equals to 0, you forget that there's a capacitor here, okay, and you replace that capacitor with a wire. So you already know how to solve these problems. You can figure out, you can make loops, you can find effective resistances, you can figure out different currents in different resistors. Okay, so for t is equals to 0, the tip is that you need to get rid of capacitor and replace it with a piece of wire. Okay, now at t is equals to infinity, just get rid of the capacitor. Okay, the step one is same, get rid of the capacitor and don't do anything. Don't replace it with a piece of wire. So the circuit now will be like this. When t is equals to 0, you replace that capacitor with a wire, and then you have circuit this, and different things can be calculated. You already know how to solve a circuit like this. At t is equals to infinity, you get rid of that capacitor altogether, and then there's just this little gap here, and because of that, what will happen is, let's say if there's some current I1 here, some current I2 was here, and then let's say I1 was here, I2 was here, I3 was here, there will be no longer any current I3, because current is the transport of the charge, and there's a physical gap here. So this current I3 will not exist, which means that you can get rid of that entire branch. Just get rid of it. Okay. So when t is equals to infinity, get rid of capacitor. That's it. Do not replace with anything. Now circuit becomes even more simple. You just have R1 and R2 in series. You can calculate what current is going through each one of them. They will be the same, because the current will be the same because the capacitors are in series, and different things. So that's the quick tip for you.